तुमको नहीं मिला पासवर्ड जस्ट वेट। तो आज के और कंप्यूटर सेंटर की वेबसाइट अवेलेबल है हमारे। देख लो भाइयों,
ये कहाँ पे करना है, किसको भेजना है? ये आ गया
ये YouTube लिंक इधर आइए ना, इसको YouTube कैसे भेजो? YouTube लिंक जो है आपका आज का, कहाँ भेजोगे? उसको व्हाट्सएप भेज दे। व्हाट्सएप लोग, आप व्हाट्सएप लोग, व्हाट्सएप लोग, व्हाट्सएप लोग और लिंक ले लीजिए। मेल कर दीजिए। आप लिंक कर दीजिए।
एक अपना व्हाट्सएप देना।
किसी बच्चे ने लिंक ज्वाइन किया गया? नहीं भेजा नहीं, मैंने भेजा नहीं, म्यूट कर देना आप। यहाँ पे कोई ऑनलाइन लिंक ज्वाइन मत करना बेटा, ठीक है? कर लो तो उसका ऑडियो म्यूट कर दो बस।
हाँ, ये प्रॉब्लम क्या कर सकता है? कई बात हो गया।
शेयर करने जा रहे हैं
यूट्यूब का ना, अरे जब आप लोग आए ना,
यूट्यूब लिंक कहाँ भेजा?
उनको भेज दिया, हो गया, लिख देख रहे।
हाँ वो तो
इसका नाम क्या है? तो नंबर है ना, ये भेज रही हो ना, हम लोग आपकी
यहाँ से ये इसे कनेक्टेड है।
अब टीवी स्टार लगा रखा मैंने यार, तुम लोग ये चल रहा ना यार। वहीं से था ना।
हेलो हेलो, हेलो बोल बेटा, वर्कशॉप में क्या है? हाँ अभी फ्राइडे आ रहा हूँ, टाइम लगेगा, स्टाफ नहीं है। चल स्टाफ भेज रहा हूँ, चल रहा हूँ, स्टाफ भेज रहा हूँ भैया, आगे तो भेज रहा हूँ। हेलो, हाँ एचआर आ गया, पीआर आ गया। हेलो,
नहीं रुको, ये बंद करो, ठीक है? ये बंद मतलब वर्किंग, ठीक है? बहुत सारा वर्किंग
अभी काम हो गया, तुम होगा अफसर को आए तो बैक कर रहे उसका कर दिया,
मैंने रिफ्रेश तो कर दिया,
मैंने उससे ले लिया ना। तरुण नहीं आएगा, अभिषेक कहाँ है? तीसरा रूम खोला किसने? तीसरा रूम किसने खोला? हमने चाबी दी थी, उसने से खोल दिया, चला गया। खाना कोई बात नहीं, ये तो जरूरत नहीं है, Zoom इधर बहुत पर देख ले, चल रहा चल जाए।
सिस एडमिन चलता है ना,
जो सारे फालतू जो उड़ा रहे ऊपर रखे यहाँ पे।
सिस एडमिन जीमेल पे चलता है ना आपका।
उससे लिंक आ रही है, उसमें लिंक आ रही है।
मैं उससे भेज देता हूँ ना आपको।
यार मेरे पास नहीं है, कोई बात कैसे, मेरे पास लिंक नहीं आएगा, देखना लिंक मेरे पास आ ही रहा है।
तो उसको मेल कर दो ना, क्या नाम था उस लड़के का।
ये कर देता हूँ, उसमें आया लिंक, लिंक है, लिंक है
आपको तो सिर्फ वो
हैं? अभी लिंक नहीं जाता, नहीं चल जाएगा बस, इससे लिंक आएगा।
नहीं अभी नहीं।
क्या चला है?
सर ने आपको मैडम का एक पॉटेड प्लांट का कहा था, उसका क्या हुआ?
क्या करना था?
पॉटेड प्लांट अभी जो
अच्छा।
कहा था मंगवा के मैडम को दे देना, एक बार फोन करके आपने, तो आपको लाइब्रेरी से आपको खाने को आएंगे आप।
स्टैंड बाय में मेरा 30 ब्लॉक है, क्लास के पीछे ही कोरोना वाले फिर से ले रहे साहब उसके बाद नंबर 7 की बिहार सेल्फ सिंपल बात क्या मेरा, इट्स अ गुड वन एक्चुअली, आई केस उनका डाउन होता है देन अंडरस्टैंड बाय उसकी चाहिए।
ये लिंक है, इसको किसको भेजना है? नहीं यार, भेजो बस। वो नहीं, ये नहीं।
कोई अरे आउट नहीं आया क्या?
का कैमरा।
हाँ बोल बोल हीरो, अरे बोल भाई सुबह भी बोल बोल, अरे एक बार वहां चला जा 307 में, 307 में प्रोजेक्टर नहीं चल रहा है, एक बार चला जा 307 में चला जा, प्रोजेक्टर नहीं चल रहा। नहीं आता, आना चाहिए, मैं सीखता नहीं। क्या होता है यूट्यूब तो 500 ऊपर जाओ यार। अच्छा जूम की 500 की लिमिट ले रखी है, इनके 800 होते हैं, 500 हो तो यूट्यूब पे देखता हूँ, वो कोई जरूरत नहीं है इसकी। ठीक है ठीक है, कितनी ज्वाइन किए 500 मैंने अभी this is your Zoom card. Meeting has been live streamed. Got it. Okay. ठीक है, अब देख कितनी यूट्यूब चल रहा है, क्या होता है चल जूम चलेगा, चलता है कोई बात नहीं, क्या बोल रहा है हिंदी ठीक है। अच्छा डिफॉल्ट बोला था तुम्हारा, वो कहाँ है क्या, व्हाट्सएप क्यों नहीं आ रहा भाई, व्हाट्सएप टाइम लेगा, इतना सा टाइम लगता है यार, वो क्या चाहिए नहीं वो 500 मतलब नहीं, सुन 500 डेट कर रहा है। अच्छा वो ले तेरे को दे रहा हूं, जैसा बोल मुझे कोई आई डोंट माइंड, ओके मुझे भेजो, मुझे लाइव स्ट्रीम दिखाते हैं, इसको भेजो, इसको भेजो, ये तेरे को किसको गए तेरे आया नाम से मुझे भेज रहे तेरा ये मेरा नहीं है, ये मेरा तेरा सीयू मेरा कैसे लग गया, इसी नंबर तो है मुझे सेव्ड है, ऐसे हो रहा है उसमें मेरा ही है ना,
सही है, बेटा देखिए।
हाँ तो नंबर का कैसे हो गया, दौड़ भी देखो क्या आया ना, देखो अब आया, अब समझ गए, अब समझ गए तेरा नंबर कहाँ है, तेरे से तो बात हुई थी ये ना, ठीक है लोगो देखूंगा, वो बनाए सीरियल बनाए, हाँ लोगो मैंने बनवाया है, सीरियल बनाया आने तो मैम, क्या हो गया? अब वो चोरी कहाँ रोक रखा कभी ना, कभी करता है यहाँ। जब आप ईमेल मिलेगा उसमें कंप्लीट हुई थी मेरी, सिर्फ एडमिन से कोई मेल हो गई थी, फिर मेरी पेशी हुई थी। ठीक है, मैं कहा ले लो उसको पासवर्ड, मेरे कहा जा रहा है, पेशी हो गई थी मेरी एक बार। मेरे थोड़ा सीधी से रहा करो, ऑफिशियल है। ठीक है गेस्ट आ गए सर, आ गए आगे आगे उनको करना क्या है, उनको बोलो व्हाट यू वांट, उनको प्रोसेस करना लाइव चलने ये चलने तो बस। अब इसमें कैमरा लगाना, मुझे रोटेट कैमरा लेके प्रेस कर दिया, स्क्रीन दिखेगी, ऐसे स्क्रीन नहीं दिखेगी लाइव। सिस्टम सबसे पहले खाए पिछला टाइम। अभिषेक कौन है? अभिषेक ज्वाइन किया, यहाँ देखो ऐसा तो है। वेलकम सर, वेलकम। व्हाट अ सरप्राइज। वैसे आप हमारे अच्छा लगा सर, हाउ नाउ विल हैव रेस्ट। एक व्यवस्था अर्पिता मैम, अर्पिता मैम बात, अर्पिता मैम हाइब्रिड मोड के लिए सर से बात हुई थी। हाइब्रिड
एक्चुअली हमारे फैकल्टी मेंबर भी बाहर हैं और कुछ स्टूडेंट दूसरे कॉलेजेस के, तो वो भी जा रहे हैं टीचर्स के लिए कुछ आज ही सुबह लिंक किया है, उन्हें पहले से नहीं मालूम, आज ही सुबह किया है।
हाँ मैं कर रहा हूँ इसको लगा, इसको नहीं है ना वो वर्क करने का ये है चार्जर भी, चार्जर
आपको ये चाहिए ना
चाहिए मैं निकल इसको वहां लगा दे बैठे। चाबी मैंने रखी कभी कभी किसी नहीं करता है कभी कभी लैपटॉप मैन नहीं करता ओडी में भी नहीं करता
सबसे बात नहीं हो पा रही थी तो मैंने इसलिए आपको करा। इसके नहीं वाली बीजेपी वो दे दो क्या दे दो ऐसे भाई के नहीं ऐसे भाई के अरे ऐसे भाई ऐसे हम क्यों अच्छा ठीक है क्या हो गया एक काम लैपटॉप में एक बार इधर कर लैपटॉप इधर करके यहाँ लगा के चेक कर चेक करने के लिए कर सकते हो क्या चेक करेगा चल रहा है इससे चल रहा है तो फिर वो भी हो रहा है बस ठीक है उसका चार्जर दूसरे केबल से चल जाएगा नई केबल से पावर फिर यहाँ एक्सटेंशन कोड अभी खत्म और एक बार रिजोल्यूशन चेंज कर दिया रिजोल्यूशन ये थोड़ा देखे तो हो गया फोटो सेशन में उसके लिए तो इसमें नहीं चलता वो हाई रेजुलेशन पे चलेगा
3 मीटर 3 मीटर ये हमारे पास
दो पोडियम के साथ माइक के स्टोन की
तो भाई अलमीरा सारी आधा होगी नहीं
To guide us through this topic, I would welcome Dr. Rajan Gupta, who is the VP of Research and Analytical Data and a member of Body in the COVID Data Scientist 2022. It is a prestigious award
क्या कर रहे हैं बोर्ड
नहीं नहीं यार तो अपना करना है
कैसे याद है
इसको उठा लो
चार से
हाँ है सर
The completed with Masters of Computer Application from Ministry of Delhi, Masters in Management from Institute of Management Technology, Ghaziabad, and Masters in Business Analytics and Business Intelligence from IIM Ranchi. He then did his PhD in Computer Science from University of Delhi. I would also like to extend a warm welcome to all the teachers and instructors present here, without whom this workshop would not have been possible. I would request Arpita ma'am to present a token of appreciation. Now I would like to request Dr. Rajan sir to start the workshop.
Morning, everyone. Can you? Great. So, first of all, thank you very much for having me here. Thank you, ma'am. One thing I think that was missing from the introduction was that I was also one of the founders of Data Analytics Club in this college. So, and this was one of our projects that Arpita ma'am, myself, and there were a few more colleagues who envisioned that we have a Data Analytics Club where industry academy interactions can be enhanced and we can have more industry experts coming in and taking care of the application side of data science, because this is an applied field. This is not something which is very theoretical in nature. And whatever you are learning, you need to understand what purpose that particular concept or technique is for. So that means you have to be constantly in touch with what is going on in the industry. And that is where we thought that Data Analytics Club would be a suitable platform or a forum for that interaction. So I'm surprised that after launch of this Data Analytics Club, few years after the launch, I myself standing on the other side. We were inviting the speakers earlier, but now I'm standing here as a speaker myself. And thank you, ma'am, for inviting me. And I think today we'll start with a very important concept, which is workshop on time series analysis. It's a huge and a vastly used concept. Time series analysis has a lot of areas, a lot of applications that we talk about. So this is an immensely popular area which holds true relevance these days. And I been standing here will give you more of industry insights rather than the theoretical insights. That's what my intention is, that touch points that you're seeing in your regular lives. The same way each industry, each organization is now becoming data driven. Now, being data driven means you are making your decisions based on data points rather than gut feeling. And that is a major transformation that is happening in industry these days. You talk about any of the big four consulting firms, any of the retail firms, any of the automobile manufacturing, you name any of the firms, everyone is highly dependent on data these days. And that is where data analysis process in itself becomes very important. So whether you are at any level, junior level, mid level or senior level, you have to take data into consideration while making any sort of decisions in the organizations, which may have direct or indirect impact on your business. Now, it may lead to revenues, it may lead to optimizations, it may lead to, let's say, cost cuttings, it may lead to some sort of customer it could be anything. The measurement of the outcome that you are putting on the business can be in any form. And the process of analyzing or picking up important information around the data set is what we are calling as data analysis. Clear? So in between, whenever you have any doubt, you can raise your hand and we'll keep it interactive. Right? We'll answer the questions in between. So you can just get an answer. Now, there are a couple of stages that we go through when we are following a data analysis process, which is very important. If in case we are not following this process, or if we are not going in a very straight kind of a path, it may lead to a lot of confusions for the decision makers. Whether to trust the process, the outcomes or not. Houses comes up with. For example, a lot of customers are visiting my online retail website, but they are not buying the products. That's a problem for me. That I'm able to attract the customers, but not able to sell them enough items. This is a problem for me. This has nothing to do with analytics at this stage. We'll use analytics to solve this problem and take certain decisions, but at this stage, it is a pure business problem that I'm getting customers, but they are not buying my products, whether it's in a mall, in any of the local shops, or online retail store. So then we start thinking that what would be the data points that we can collect? What kind of problem this is, which we can say that this is an analytical problem to be solved. And then we come to the second phase of analytical problem formulation. What kind of data analysis I can put in? I need to understand what data points I can collect around that problem and what kind of analytical techniques I will be applying on this. So that formulates the second phase of data analytics, which is the analytical problem formulation. Then once we have identified the problem, once we have, as a data scientist, as an analyst, I identified which all techniques I'll be applying, then comes the data understanding in itself. You want to understand the data. What is the look and feel of it? Because you are going to take decisions out of it. You are mining it. You are extracting information out of it. Now that information has to be extracted in a meaningful manner. You can't do an ad hoc analysis or a random analysis which has no meaning at all, right? So before conducting any sort of analysis which is more meaningful, which is impacting the business processes, you first try to understand the data, and that is where you apply basic statistical measures like mean, median, mode, standard deviations, ranges. So basic measures of dispersions, centralities, and skewness, kurtosis. So all these kind of basic statistical tests which describes the data, that is where you start with, and you do some sort of visualizations just to see what kind of distributions are there in my data set. You start with visualizations on univariate analysis, which is based on just single variable, bivariate analysis, which is based on two variables, and multivariate analysis, which is more than two variables. So you can have any number of features or variables in a data set. Now, these are some of the specific terms that we use in data science day to day, data analysis day to day. So a data is nothing but any touch point, any kind of factual information that could come in the form of rows and columns. If we talk about simple numeric data or a time series data. To rows, we are saying them as instances, and to columns, we are saying them as variables or the features of that data. Now, if you just study or understand about a retail transaction on Amazon, and I'll keep on taking this example because this is what we deal day in, day out, right? Everybody knows Amazon. Anybody who is not aware of it? No, right? So we are making decisions with respect to shopping a particular product or even browsing on Amazon. But just imagine whenever you are buying a product, there are certain features that gets captured, which is your ID, email ID, your phone number, your address, the product that you have bought, the price of that product, what is the delivery date, what is the order date, and all those. So these become the features of the data set. And you being the single buyer right now, you become the instance of that data set, right? One row. There could be multiple instances, like there could be multiple buyers who are buying from the Amazon site. So you have multiple rows coming up populated in that data set and multiple columns which are there. So we want to understand the characteristics of each feature. That means how many users in which region we have more buying patterns coming up, what kind of products are more selling up. So these kind of basic questions, basic business questions comes up in the third stage of data analysis, which is data understanding. And with data understanding only, you can answer a lot of questions. That will be our focus today as well, that when we are handling time series data, then a lot of questions can be answered with data understanding only. You need not to get into the most complex of the models every day and every time, because everybody is not a senior data scientist who is solving the complicated problems day to day. We need very less number of advanced data scientists or senior data scientists, but more number of analysts who can give me a good data understanding, who can make me take certain decisions which are data driven and which can help in kind of making my management, making my team understand what kind of trends and patterns are emerging out of the given data set. So that is the data understanding stage. And then combined with that, we go on a more advanced stage of descriptive analytics, which is kind of similar, but right now the focus was more on visualizations and data understanding. So now we come up with more of more advanced statistical measures in describing the data in a better manner. So we just keep on increasing the complexity of our analysis with each stage. And then the diagnostic analysis comes in, where we are doing a lot of inferential statistics and data mining with respect to, let's say, we understand that the data has got a lot of noises in it. Now, what do we mean by noise? Now, data is static term. How can we get noises out of it? So the noise in itself is a term which is used to find out any anomaly in the data set, any kind of missing values, any kind of out of the range values which we are calling as outliers, any of the data types which are not mapping with respect to features. So we see all these things. Whenever you're doing any sort of programming, you are taking care of data types, right? Now those data types mismatch is a common issue in industry these days. You do not get a very clean kind of a data set, and which makes the job of an analyst even more important, that he or she must understand the different kind of data types. The data types that you're studying in your programming languages, they're actually applied onto the industry applications, where during the noise removals or noise reductions, we are using the type conversions and understanding what kind of data types we have to use. Then once we have understood what kind of types, what kind of issues we have, what kind of noises we have, we then go with the pre-processing part. We have to treat them, basically. We have to remove those noises so that when further analysis is being done on the data set, the results are more accurate and more efficient. It should not be that you have performed an analysis and that is giving you spurious results, that are giving you incorrect results. That should not be the intention. The intention should always be that we are taking care of all the impurities in the data sets, all the kind of outliers or missing values which are there. We should either drop them or treat them. So there are multiple ways around it. So you do the data pre-processing, and then comes that which all features would be important. Now, in a small database, you may have just 5 or 10 features. But in industry, sometimes, let's say we are working with sensors data, it may span up to 200 or 300 features. That means 200 to 300 columns. In text, that could be 5,000 or 10,000 columns. So the number of features or the number of columns can be a lot in a lot of use cases in a lot of data sets. And that is where we have to be very concerned about feature engineering. And sometimes it also happens that you have very less number of features to understand and to analyze your data. You may just have 2 or 3, which is the case with time series. In time series, you will get hardly 2 or 3 columns or 4 columns every time, because the time dependent data has to be in a very limited manner. So then it becomes important for us to understand what kind of features are useful for information extraction, information building, and if I have to create new features, the permutations and combinations is covered up in the phase called as feature engineering, where you also do some sort of transformations around the data, you do some sort of scalings around the data, standardizations, normalizations. These are all statistical measures. You're basically trying to put data into the most appropriate distributions through which we can get better results. Better results because our business is dependent on decisions. Now, which product to put on sale on the Big Billion Day sale day, which is coming up probably this month, this month as in next month, October, a lot of analysis goes behind it. What kind of product should we put on sale on Big Billion Day? What kind of customers we should target? What kind of regions we should promote ourselves? These are billion-dollar questions because a lot of marketing, a lot of campaigning goes behind it, and a lot of revenue is being spent on that. Right? So you can have heavy cost implications if you are not selecting the right features. And that is where feature engineering becomes a very important task while doing the data analysis. Once you have prepared your data with respect to feature engineering and you have selected the right set of features, then comes the modeling stage, which is where most of the attractive packages comes into consideration. Most of you have heard about regression, classification, clustering, time series forecasting, maybe some sort of deep learning models, neural networks. All these are modeling techniques. You're actually trying to learn from the past data and predict for future. That is where a lot of predictions comes into picture. Now, before predictions, a lot of descriptions comes, which is the initial phase. So you're describing the data a lot in previous stages. You're diagnosing the problem that, probably this product is better than this. This region gives me more sales than this region. So let us target our marketing campaigns in this region. This region is weak with respect to product sales. Let's promote our, let's send somebody who is locally known in this region. Maybe some brand ambassador, maybe some sort of cricketer in that region, maybe movie actor or a local actor or a local politician who is endorsing that also. These kind of decisions comes in while you're describing and diagnosing your data. But now during the modeling part, you are actually predicting something. Now predictions is something that based on what you have learned from the past behavior of the data, you are predicting in future. Right? Any example of predictions? Sorry? Weather reports, right? So weather reports, you see that on a daily basis, meteorological department is giving us alerts. And even today, Yamuna is on high alert right now. If it rains more in Delhi, probably the nearby regions has to be evacuated. Now, these strategies has to be planned at government level. So government has to decide based on what are the forecasts or conditions that are being given to us. And those forecastings are being done based on the data points. Now, previous year at this time, what was the condition? In past weeks, what has been the condition? In past so many years, what has been the condition? So you keep on considering the amount of data that you have recorded in past many instances, and then you try to come up with a forecasting model, right? All right. So predictive analysis also comes with prescriptive analysis, where most of the optimizations, most of the operation research modeling that are there, we're trying to pick up the most optimized technique to find out the answers to the business problems. Again, they are a different league which we are practicing day in, day out, and a lot of advancements is required when practicing prescriptive analytics. So that is an advanced field that I would say. But these days, whatever different types of modeling techniques you are seeing, that is only comprising just one stage of predictive analysis. Whether it is computer vision, where you are doing the image analysis, object detections, video coverages, whether it is textual analytics, sentiment analysis, or kind of Twitter analysis, Facebook analysis, any sort of online reputation management that is being done with respect to text and comments. That is again a kind of a predictive modeling. We are just sensing, learning from the past behavior and just sensing what will happen. So text, images, videos, audios, numeric data, and time series data. These are the different data types according to which this entire process of data handling, data modeling, and model evaluation varies. So different type of data means different type of analysis journey. But the journey, the broad concepts around those journey remains same. So that is something that we have to be sure of, that this journey we are following on all types of data sets, be it images, be it audios, videos, text, numbers, or time series. Then we also go for, once we have created the model, we also deploy it on our servers. Because we want to automate the process. We want to utilize the learning capabilities that we have had from the past data to be able to predict maybe in near future or in long-term future. And we keep on learning from the newer data sets that we encounter on daily basis. So as we keep on getting newer data, our model keep on updated. So that is the journey where deployment and maintenance comes into picture. And finally, we also try to understand what are the business outcomes. That is the key, right? We started from a business problem formulation and we have ended with respect to the business outcomes. Between this, all the data analysis phases have been kept, right? Ultimately, it's all about decision making. So what is the outcome? What is the return? What are the ROIs? What impact can we see from this particular pattern that is emerging? That has to be answered. This product is better or this product is better. This region is better or that region is better. How much discount should we offer? Should we offer 40%, 50%, 30%, 20%? What is the consumer behavior, right? You'll see a lot of offers, and specifically with respect to a brand called as Canterville, they come with 50 plus 70%, 50 plus 60, dual kind of discounts. Because consumer behavior thinks that it is kind of a free. We are almost getting 100% discount. But the arithmetic says something else, that you are getting effectively 60 to 70% discount on a very high priced product. So that kind of a consumer behavior comes from analytics. We understand what kind of consumers are picking up the products at what kind of prices, and accordingly we adjust our discounts. So these are all system generated discounts, which is based on heavy data analysis and heavy kind of information extraction out of the past data, right? Any questions on data analysis process? All of us are clear that what exactly is data analysis, because we'll be focusing on the first 2-3 parts, that how do we convert, consider them while bringing out our data analysis hats. Now there are a lot of domains also that comes into consideration. Domain is a very, very, very essential process or kind of an information that we need to know. Now, for example, if you are working for a hospital, you need to understand their terms. You need to understand their terminologies before coming out with any sort of analysis, right? Now, data points will remain very specific to that domain, but the concepts that you apply will also be common. For example, if you want to find out the average of something, the average will remain average, right? Mean will remain mean. Standard deviation will remain standard deviation. What else will change is the domain knowledge. What kind of variable you have to pick up? What kind of feature you have to pick up? What sense you have to make out of that feature? That is what we call as domain understanding. If you are not aware of the processes of that domain, if you are not aware of the key terminologies of that domain, it becomes very difficult to flourish in this field and to understand and to bring out any meaningful information. It would just be kind of calculating few mathematical operations on the data and that's it. There won't be any relatability, there won't be any impact that we could get out of it, right? So domains are many, and we are working on various industries and functional areas, industries like healthcare, automobiles, CPG, retail, manufacturing, travel, tourism. So these becomes the industry sectors. They are business in themselves, right? They are actually dealing with customers day in, day out, and they're generating business. Business in the sense they're generating revenue out of the customers. Customers are paying for the services. That is where what we call as an industry. IT is more of a support services, IT and analytics. Now, IT and analytics is a support services in the sense, in itself, they are not dealing directly with consumers, right? They are dealing with businesses to solve their needs. Let's say this college requires an IT infrastructure, because it is directly dealing with the admission processes and everything. But IT people are dealing with the college, right? So the infrastructure is dealing with the businesses, but the core business is not what we call as IT analytics. So we'll say that these are all industries which are directly revenue generating. Now, there are certain support functions in every businesses which we call as functional areas. For example, human resource management. Staff would be there in any of the business, right? So to manage them, to understand them, to take care of their needs, there are a lot of processes that goes into. Finance department is something which is cross verticals, as in it is available in every industry. You need to have some salaries being compensated. You need to have taxes being calculated, revenues, costings, any sort of upcoming forecast with respect to projections. So everything has to be managed. So the functional areas are across the verticals, where we are using a lot of analytics. We are picking up a lot of data points. We are making decisions. We are making policies based on them. And they are not specific to any sector, but they are specific to a functional area. For example, the HR policies are generally similar in most of the organizations, except some of the organizations who wants to be there in the limelight, they come out as, let's say, 4 days work culture. They'll come out as flexible work hours. They'll come out as, let's say, only work from home or hybrid mode. They'll come out as that we have a very large or huge infrastructure at our workplace. So these kind of certain differentiators that they come up with, that they may come up with, but most of the common processes, like once you're joining an organization, what kind of documentation is required, that remains kind of common. So functional areas are mostly common across the verticals, and understanding of the functional areas and domains helps us in business problem understanding and identifying what kind of outcomes are impacted by the analysis that we are doing, right? Any doubt here? Okay. A lot of questions comes in that this field is only for people from computer science, which is kind of not true. In industry, as we are working, as we are seeing a lot of people joining analytics, science, a lot of people from non-computer background are coming up. Because it is, whether it's economics, whether it's management, whether it's humanities, whether it's healthcare, any course that you are covering up, any graduation and undergraduation, post-graduation courses that you are doing, every field requires data analysis as a skill set. So it is a myth when we say that data science or analysis is only for computer science. Yes, programming may be better for the people from computer science background because they are doing it from the day one. But for others, now there are a lot of low-code platforms which does not require any programming for data science. And our company is doing that as well. We are creating a low-code or a no-code platform which can be utilized by managers, middle managers, and senior managers to understand and execute the process of data analysis rather than going through the traditional approach of coding practices. Coding is just an enabler of executing the concepts. The concepts are common across all the fields and verticals. So this is a myth if you consider that it is a field only for CS. This is a field for everyone, and this will become an essential skill set whenever you will be entering into your jobs. Just the way computer understanding and computer knowledge was considered as a primary skill, whether you're coming into any of the professions, whether you're joining any of the organizations, knowing computers was essential, right? So 5 or 10 years back or 15 years back, this became a mandatory requirement. You should know computers. That's a skill that you must have, whether you are an accountant, whether you are an HR expert, whether you are into administration, whether you are into any other profile. You have to know computers. The same way you will have to know data analysis, because now on computer you have to deal with a lot of data regularly. So this skill will be required for people from all the backgrounds. It is not just CS specific, right? Okay. So a lot of generic things. Now let us come to the meaningful part of today's talk, that we are covering up two important libraries, which are essentially the NumPys and the Pandas. Now, NumPys and Pandas have got very rich history and a lot of numerical computations and a lot of panel data handling was being handled by these two libraries, NumPys and Pandas, where a lot of faster operations were being performed, a lot of efficient computations could have been performed with the help of NumPys and Pandas, and that is why they are becoming widely used in industry these days. If you know good skills, if you know a lot of functionalities around Pandas and NumPy, probably you will be absorbed very quickly. So as a beginners, if you really want to focus on these two packages, NumPys and Pandas. They give you a lot of flexibility as an analyst to enter into any of your jobs, right? So NumPys and Pandas are something which has kind of structures in the sense, structures in which data is stored. NumPy has got arrays and Pandas have got data frames and series. These two are very, very, very important data structures that we use day in, day out. Whenever we are reading the data, it is coming most of the time through data frames and series. And the prime reason for using them is that a lot of functionality has been developed in these two packages, which can help know if C++ is still there, the course, right? So as compared to C++, where you have to code everything on your own, that means even if you have to write search and sort algorithm, you'll have to write the few lines of code. You'll have to use constructs like loops, conditional statements, if there's use of a lot of operators. But with the advent of these packages, all of these programming has gone away. You just call a function called as sort, and your work is done. Now, whether that is being done in an efficient way or not, that's a separate discussion point. But to ease your processes, to ease the regular day-to-day operations, the functionality which these two packages are having now is tremendous, and it's very powerful that you can do your job easily. Now, there could be two set of debates that can happen. One is on the implementation side, that whether we are implementing them in a most efficient manner or not. That could be a point of discussion. But right now, most of the people have to come up with some sort of analysis and which can help in quicker decision making. So that is where the quick part is being resolved right now with a lot of inbuilt functions in these libraries. So the kind of structures that they are having that allows us to perform any sort of operation in a very quick manner by just calling a few inbuilt functions that can quickly execute on these kind of structures. So that is why the two libraries becomes very important. And whenever we are talking about data handling, Pandas and NumPy is the kind of lookup to packages that we generally use. Now, in general, apart from arrays and data frames and the series that these two packages are offering, Python itself has got a lot of data structures, inbuilt data structures, which are used very prominently. Structures, those who are from non-CS background, data structures are nothing but containers to hold data sets. Now, the data has to be stored in some format or the other, and those formats, those containers, what we call as data structures. So in any kind of format, the most important thing is that we should be able to quickly access that data point, and secondly, perform the required operations on it quickly. So with respect to that, we have lists, strings, tuples, sets, and dictionaries as the most widely used data structures in Python, which kind of helps us in understanding how we are storing the data, how we are manipulating it, how we are adjusting with it, primarily because of the first few phases of data analysis, which was around data understanding or the descriptive analysis. Once we have the data captured into the right data structure, then the analysis comes into consideration. And of course, we have a very peculiar function called as slicing and dicing, which is just extracting some sort of information, some sort of values out of the given data structures, which we prominently use during the data understanding or the descriptive analysis phase. So slicing is nothing but some kind of an operator that we put in operator as a colon. We use the indexes to fetch that much of information out of the data points. Now this information, for example, we have stored a word called as hello with an exclamation mark. Every character is a data point for me. Every character is a data point for me. So if I want to extract just few of the characters out of it, I can perform slicing operations. Now this is a very small example of hello. Just imagine a larger example that you want to extract the product sales under electronics category in Agra region. That is a very peculiar thing that you want to extract out of the overall sales transaction data at India level. Now, if that has to be extracted, that has to be done through the operations known as slicing operations. In Excel, you can apply filters, right? How many of you know Excel? Okay. So most of you who have not worked on Excel, we can apply filters. We can just select the regions for which we want the data for. We can just select the product category and the data will be filtered out. That is also kind of slicing that we are doing. We're extracting some information out of it. The only difference is that that data or that operation is done through UI. That means you have some buttons, some functionality coming up, which you are just utilizing on Excel and then getting the data extracted out of it. Here we are doing it programmatically. So we are using Python operations where we are just using an operator inside any of the brackets according to the data structures that we are holding. Right? Any questions on slicing? Fine. Everybody is clear till now? Why we are discussing all this is because in further commands, we'll be utilizing all this. So that is why we are just creating a base that everybody understands what we are executing on the commands. Right? Right. Now let's come to the today's topic, which is around time series. There are different types of data that we deal in day in, day out. And those data sets comes with a lot of inherent features. Now, first and most important type of data that we deal is the numeric data. That is pure numbers. Now, those numbers can be coming from a quantity, for example, price of a product, number of items purchased. They are pure numbers. And some of them could be qualitative. For example, color of the product, red, green, blue, maybe. We convert these quality into numbers again. Let's code them red as 1, green as 2, and blue as 3. Again, we have converted the quality into a quantity. We've converted that into numbers. So these kind of data that we deal in with respect to absolute numbers, which has got some meaning in itself, in independence, we are calling that as numeric data set. Right? Now, when this numeric data set is dependent on time, that means its relevance is associated with time. That kind of data we are calling as time dependent data or time series data. For example, weather. Yesterday's weather would always be associated with yesterday's date. Right? Can we say that weather holds relevance today? No. Day before yesterday? No. Yesterday's weather will always hold relevance with respect to yesterday's date and a specific time maybe. It can never be considered as an independent entity. Let's say the weather was 32 degrees Celsius yesterday recorded at 8 a.m. It will always be recorded with respect to 8 a.m. 32 degrees Celsius in itself will not hold any value. Agreed? Similarly, stock prices. Yesterday, the stock price of a company was, let's say, 540. It will hold its relevance only for yesterday. Today, it may have a different price. today's price will hold its relevance today only. Yesterday's price is gone. Now 540 does not hold value. What is today's price tell me? Right? So again, it is highly dependent on time. Let's say you are monitoring a patient in a hospital. You are all seeing screens which are monitoring patient's health, right? Maybe in movies, maybe in television, serials, or OTTs, or maybe real. Now, the kind of monitoring that is being done, it is on second basis. Every second you are coming out with vitals. What is the heart rate? What is the blood pressure rate? What is the pulse rate? What is the body temperature? Everything. Now, in past, what was it? In previous second or 3 seconds before, what was it? That does not hold relevance. What is it now? In today's context, in this second context, in the present, the patient may fail. The heart rate may go down or highly up. Similarly, but blood pressure may go really down or really up. So what is it that is now the condition? So again, the data point that you are capturing is highly dependent on the time component. Similarly, what were the sales number last year? What was the sales made in previous quarter? What was the sales made yesterday? Does not hold relevance. What is the sale that is going to happen today? So all of them are dependent or associated with a component called as time. Time can be in the sense of days, date, months, years, hours, seconds, milliseconds, nanoseconds. It could be anything, right? Any other example of time? The OTP that you get. It is valid for only 10 minutes, 15 minutes. The OTP that you are doing for net bankings or maybe cab booking or maybe any other thing which is OTP enabled, that has no time, right? Time relevance is there. If you use it after that time interval, it has no relevance. It is useless, right? So that is where time series has its own properties and time series has its own ways of getting manipulated and understood. We cannot consider time series data similar to what we see in the numeric data sets. Because numeric entities can be considered independently, but time series cannot. This has to be combined with certain operations. This has to be associated with what we call as time. And time can be measured in various ways of year, months, days, dates, hours, seconds, minutes, right? Clear? So these are some of the time series data utilities that we have found. A lot of predictions were happening during the COVID era. How many cases will come up? Why do we need to know how many cases will come up? Why do we need to know this? To do analysis of death rate. And what will you do with death rate?
To predict the resources that will be required.
Right. It's more for resource planning. Let's say oxygen cylinders, let's say hospital beds. Government was doing this daily basis. Every hour they were understanding what is the forecasted value, which was dependent on time. आप 4 दिन बाद hospitals के beds arrange करोगे or maybe 5 days, after 5 days you are arranging an oxygen cylinder will not make sense to people who are critical now, right? So that's why the COVID predictions saw a lot of time series dependency, a lot of forecasting predictions were done around it for a lot of resource planning, right? And this was not just with Delhi or India, it was happening worldwide. So a lot of time series principles were being involved in understanding how many patients would be there. Of course, there would be mortality rates, there would be death rates, there would be infection rates, there would be other kind of rates that were all there, but they are all with respect to what kind of resources we need for each type of inputs that we are getting. So this becomes a very important utility. Another important utility with respect to machines that we are seeing is with respect to IoT. A lot of sensors are sending data to the servers for analysis. You guys must have heard about smart routers, smart sensors, maybe smart machines, In fact, up to probably you'll see a lot of air conditioners, a lot of washing machines, a lot of cars, refrigerators. They are all based on smart sensors, right? They can sense a lot of things. So what does that mean? Does that mean that they have developed intelligence? Is it like some human is sitting out in these machines? No. They are all sending data through which some analysis is happening on the servers, and the decision is being transferred back to these machines what to do. Right? Either the processing is happening in the machine itself, or they are connected through a network through which they are sending signals. So every second, whatever data they are sending, that is being getting analyzed and reflected back onto the machines, and some decisions are being taken. The same way you guys are taking decisions. If you touch a hot thing, immediately your brain processes that this may be harmful for your skin. Your reflexes work and you take your hand away from that hot thing, right? This happens with everyone. The same things are also sensing. So what is the temperature? What is the let's say burn rate inside a machine? Let's say some part is getting heated up. For example, in a lot of automobile companies, and we were working with some of the large automobile giants, and their battery drainage was a problem. So we were able to sense what are the battery conditions based on the sensors that they are sending it to us. Similarly, a lot of driver behavior is being sensed through accelerator, brake, clutch, and gearbox. Whether he is doing rash driving or not, the sensors are sending the data, and that is being sent every second. So again, today at this particular time, these were the road conditions and these were the driving conditions that happened. Again, that is a time series dependent data that we are capturing and solving for, right? So time series in itself has got a lot of utilities, and that is why we are here today to understand what are the different data understanding operations that we are performing on time series. So the way I have explained you the data analysis process, which starts from business problem understanding to data understanding, and then just visualization, some sort of slicing, dicing, some sort of descriptions around it. The same thing will apply on the time series today. We will not get into the modeling part because of the time constraints, and time series in itself is a very vast area, but we'll see some sort of trends which can be covered up through moving averages. Right. So I would request all of you to just have your notebooks ready, because a lot of commands that I want all of you to execute parallelly, because they will be giving you different results what is there in the static notebook. This notebook I have executed yesterday, so again it is time dependent. What the results are there in it yesterday will not be there today, because most of the things are time dependent and time has changed today. Yesterday it was a different day, today it is a different day, right? So just to give you an overview, we'll have these many areas being covered up, and they are all simple commands that I have written. They are not complicated that we would require too much time to compute or to execute them. But nevertheless, I'll focus more on their utility, what are they being used for, and then you keep on executing them parallel. So first is date and time data types and the tools that we are using. The objective of this particular section is to understand, to determine different date types and formats of time data. Now, time data can be in year, month, date, hours, minutes, seconds format, and what are the different kind of strings and numeric conversions that can take place is something that we understand from time. So time data in itself we are first understanding, and then we'll associate values with respect to time. So right. So there is an important package which we generally refer to as date time. This is very important, and this is an openly available package in Python, which we generally use to fetch the current time details, the current descriptions around time. So whatever format conversions we require, we generally store a lot of functions inside the date time package, and that is what we are using to fetch what is the current status, what is the current instance of time with a function called as now. So everybody understands that whenever we are importing any package, we are using the package and then followed by a dot, followed by the name of the function that we want to execute. For people who are from non-CS, that's a traditional way of utilizing the or calling the Python functions inside a library or package, right? So can you tell me what is the value that we are getting for now? Those who are executing this command. Any answer?
28
10, 38, 57, 43, 4740.
Right. So the format that we generally get from now function is years first, then the month, then date. So today's date is 28, that's correct?
Yes.
Fine. So we are getting 28 as the output. I was getting 27 because this was executed yesterday. Right? Then what all we are getting? Hours, minutes, seconds, and microseconds. Although we may not always require time component, but whenever we require, we can utilize this format. We can extract the independent values of year, month, date, and the time. So whether we want to capture the date or the time component from the current instance, we can use the now function. And now what I am doing is that we can also execute, if you will say, whatever variable. So now, for those who are not coming from CS background, now this is a variable name. Now in Python, that we have this flexibility, we can have the same variable name as we have the function names. So what I have done is that I have stored the current instance of now output in a variable called as now only. And with respect to the variable, I can access independent year, date, and month from that date. And in fact, I can also fetch independent hour, minute, second, and microsecond. So let's say I have some dependency on any one of these concepts. I can quickly, with the help of variable name, I can immediately fetch that information out for myself. For example, in healthcare, maybe current seconds would matter. In aviation, as in an aeroplane flight, microseconds will be crucial. You cannot have even microsecond of error in your decision making, right? However, maybe in financial statements of the companies, only year is relevant to us. Every year we are having financial reports coming out, and I can sort those financial reports based on. So, with respect to different use cases, different industries, we can have different time component fetched from the current instance of time to which I want to compare with some years that passed, right? So everybody is able to access these three commands. Right? At the back, we have the notebook. Good. Now, if I am able to capture the individual dates, the individual years, months, and days, that means I should be able to do some sort of arithmetic operations on them as well. Therefore, let's say I want to find out the difference between dates. What was the last date when you filed returns of the taxes? Let's say it was August 17th, and you have to file it every 45 days. Have 45 days passed? I don't know. So I do current now minus August 17th. I just pass it and I'll get the difference. Like here I am doing the difference between 30th June and 1st January. How many days are there? Right? Sometimes you have to be very specific with days, number of days, number of seconds. You have to be very specific. A lot of programming efforts goes into the threshold values that you are computing. right? Right or not? Right. For example, tickets booking on Book My Show, that is highly dependent on what is the number of seats left with respect to the time of the movie show. It will not compute after the movie has already started. It will not allow you to go, right? So with respect to now and when the date which we opened up with the bookings, how many seats have been booked? You can just find out with respect to time instances as well. So we are able to find out the delta, right? Can we find out quickly? Tell me the delta between 15th August and 26th January. Quickly tell me what is the number of days between Independence Day and Republic Day. What would be the function? Delta is equal to, or directly also we can write date time bracket 2022 comma 8. We'll write the higher order, the date which is nearer, or the later on date first and the previous date second, right? First बाद में आएगा ना? Okay, so here we'll write 8, then 15 minus
say 201.
8 times 22, 1 comma 26, right? What is the answer?
201.
Sorry,
201.
201. Right. So there are 201 days of gap between these two dates. Now this was a very generic example that we were calculating to compute the delta, but generally we use in a use case with respect to how many days have passed with respect to certain activity in the past. For that, we are just comparing the delta time that's occurring between the two dates. So it's clear, simple. Similarly, if this returns an object, but if I want to access the specific number, then I can do it with respect to dot days. Dot days will give me the specific number, which I can use for, let's say, some sort of conditional statement, some sort of looping, any sort of understanding around, computations or any decision that has to be taken up. For example, let's say a specific number have passed. For example, your return policies. You book a product, you get it delivered at your home, but there is a 7-day return policy or a 10-day return policy. Now, whenever you put up a request, automatically the machine is computing the date difference between date of purchase and date of return. If it is more than, let's say, 7 or 10, rejected. No human intervention is there. These are all automated based on date mechanisms. So delta is being considered, delta is being computed, compared with the threshold value. If it is less than the threshold value, your return policy is accepted. Probably some guy will come at your doorstep, will pick up the product, take it away. If not, you'll get a message, sorry, your order cannot be processed because you have expired with respect to the number of return days that were there. So this is an automatic logic that is there on the delta operation. Clear? Right. So for programming, you are just fetching the days as well. Now, similarly, you can also fetch seconds. I have not shown any computations around seconds because we were not comparing the difference of seconds at seconds level. We were just doing at the days level. The same thing you can do it at the time level also, the hours, seconds, or microseconds. Right? So you can just quickly execute delta dot seconds and you'll see 0 because we haven't considered it. That's a by default value. Similarly, there are a lot of times when you have to add certain number of days to the date, right? 14 days from now. Let's say I want to put up reminders 14 days from now, and a lot of calendar applications uses this functionality of adding some days to the date. So that kind of additions and subtractions should be possible for us, and that is again that's doable through normal arithmetic, where you are having the start date or the base date, which you are defining inside any of the variables, which I have done here with respect to start. And then with respect to time delta, you are using a function called as time delta and passing the number of days that you want to add. Right? Can you quickly add 365 days to your birth date and tell me what is the answer that you are getting? This year birth date plus 365 days of time delta. Let's see what outputs you get. We can take a variable birthday equal to date time. This year your birth date 2022 comma month comma year sorry date, and then birthday plus time delta 365. Are you getting your birth dates again for next year?
Yes.
Good. So these are utilized by a lot of restaurant coupons, lot of bank policies in emails. Every day you will receive an email at least from your bank account or from your any place where you have registered your birth dates. Every year, if this date is equal to now, send a happy birthday message. Right? So you are able to add the delta, time delta to a, so and these are all automated applications that I'm talking about. These are all utilizing these time series specific instances in their applications. How many of you received emails on your happy birthdays, SMS or emails? Everyone? From where? Banks?
Starbucks.
Starbucks? And
Oh,
Snapchat. Okay. Snapchat is what?
It's social
That's
media.
Social media, right? Okay. Any other places from where you are getting birthday wishes?
American Eagle clothing brand.
Clothing brands. Okay. Are there members sitting out there who are every day tracking who to wish happy birthday? No. Is that possible? No. Then these kind of logics are helping them. This is machine learning. With respect to machine learning, you are just automating the processes. Right? Okay. The way you can add a particular date, you can similarly subtract the time delta as well. So now, whatever date you have got with respect to the output from the previous, just subtract time delta 365. You should move back to your current birth date. Just quickly execute. Have you got the results? Is it the same date that we are getting? Can we do 2 into time delta 365? Twice of time delta 365, 2 star time delta. We just subtract that from the previous output. Are we getting our birthdays 2 years back? Right? Why is that required? Because of your insurance policies. You have to travel back in your insurance policy. Sir, ये तो expire हो गई है. The date of purchase was not there. या फिर आपकी age के accordingly now you cannot get this refund. Any kind of warranties, you have to move back to the time. 5 years VIP luggage warranties. Are they tracking every information manually? No. It's all system dependent. Right? So additions, subtractions around time deltas are very important and they are used in a lot of applications. A lot of applications that you see day in, day out. Start observing those applications in your daily lives and you'll see some sort of analytics being used. Some sort of data handling, data understanding is being used. It's not always about deep learning or computer vision. It is mostly about data understanding. And that is what we are doing here, right? Okay. Similarly, many times we want to convert the date time format into a string. Now, while converting into a string, it will automatically take hours, minutes, and seconds also as an input, even if by default you are not giving them, right? So that converts into a string. A string is nothing but something written in a form of characters, right? For those who are coming from non-CS, it is the combination of characters that we are calling a string. It is not numeric anymore. So a lot of time characters has to be processed and that processing happens mostly in the text analytics, where textual data is being kept. And there, we do not want any numbers to be taken up with respect to text processing. We just talk about the characters and the strings. And that is where we utilize this functionality of converting a data into string, right? So quickly execute, are you getting the timestamp through str? Str is an inbuilt function of Python. We do not require any sort of library to call this. Some functions are inbuilt and they are available openly without any packages. So you're able to get the output of your date time, any date time that you'll give, right? So I'm assuming that all of you are simultaneously executing, and I am not executing because this may disturb the flow. Sometimes errors may be thrown, but these are all pre-executed commands. Okay. Similarly, we want to use specific format of the strings for conversions of time as well. We can use date. We can just change the order basically. Sometimes you'll see in many of the forms on internet, their forms which you are dealing with, some goes with date, month, time, date, month, year, some goes with year, month, date, some goes with year and month only. So there would be specific instances. And this is a format where you can use percentage, T for date, M for month, and Y for year to specify the order in which you want to convert any particular date into the given format. So that is also doable. You can just play around with this. You can just put T after M, M before T, Y first, whatever format you want to play with, all the formats will work, right? I've shown two examples here with respect to strf time, where I am just converting the stamp, that means the date stamp which I have converted above 31st January 2022 to date, month and year, and bottom I'm just extracting month and year only. So I've removed date, right? So date has vanished, only January 22 is being observed. Is it clear? And similarly, vice versa can happen. We want to convert string to date. Now, something has been given as string, and this is the most common case in data sets that we deal in. A lot of dates that are coming in the data sets which we are handling, they are coming as strings, they are coming as characters. We are not able to do any sort of numeric manipulations on them. And for that, we have to convert from string to date. And again, the formats can be specified by us with respect to percentage Y, percentage D, percentage M. That by looking at the data, that is where data understanding comes into consideration. Just by looking at the data, I am able to understand what format 22 in the beginning. I'm pretty sure this cannot be day or month, right? That is called as data literacy. That when you are considering a date in this format 2022, 01, 31, what my basic knowledge says that first cannot be day or month, it has to be year. Second can be month or date. Third cannot be month or year, it has to be date, right? This is the basic understanding that you guys need to be aware of every day, every time. You cannot just randomly put in any format. So that is where data understanding comes into consideration. Are we good so far?
Yes.
How far is Christmas from now? Quickly calculate.
87 days.
87 days. Great. How far is Diwali? When is Diwali? 24th October. 25 days?
25 days.
How can it be 25 days?
And
Must have entered 27 days. Normally counting with Python programming. So we should use the now function and the take time stamp. We should compute that way.
25.
20 days. 26. 26 is fine. 2 days for September and 24 days for October. Fine. How far is Dussehra? 5th October.
October 10th नंतर होता है ना? 6th.
Very good. Each time will be near to Dussehra, right? So these are some of the very basic answers that you can give with respect to dates and the type conversions between strings and the dates that you can take. So we're done with this section where we were trying to get the dates in a desired format. We were doing time manipulations and differences in dates, and we were doing type conversions from string to date and vice versa. Right? Any confusions? Any doubts still here? Are we good so far? Great. Let's start with, now we have understood the different formats in which date can appear, and I can also compute the distances between the dates, right? Let's come with the slicing part now. Slicing in the sense, now we have a larger data set. I want to fetch specific portion format processing and analysis. That will cover in this section. Now, all of you are aware of this term or this command, which we call as import pandas as PD and numpy as NP. This is a very common acronym that we use. Of course, this is not necessary. You can use the entire name of numpy and pandas. You can use any other acronym as well, but this is generally a standard practice that we follow, that we are getting these libraries imported as their acronyms, because those acronyms will be used to call the functions which are there inside these packages, as told earlier, right? For all people who are new to Python, we are just picking up the library or the package dot the function name inside those libraries and packages, right? That's a very simple. And we are again importing the date time. Now I've kept this command again because now I'm considering the second section as an independent section. So whatever we execute in the second section, that will be considered as independent. So again, importing the date time. Right? Quickly, just execute this command so that all of you have these packages as readily available in your workspace in Python notebooks. Done? Executed successfully. Otherwise, error would have come that package not found or it is not able to execute that package, right? Now let's create our own data set. Now, right now we do not have any data points to work on. So what I'm doing is that I'm taking up the data from the datetime format that we have accessed just now in the first section, that how we are creating the dates with respect to datetime. Now I'm creating series of dates. Why series? Just to create a synthetic data set, just a dummy data set to work on, right? Can we quickly do this? Run this command, which is creating a series. The square brackets, inside the square brackets, we are creating the date with respect to date time separated by comma. So that will become a series in pandas, and we will be able to apply certain operations on that series. And quickly display the date. Done. You just have to shift and enter on each cell. I hope everybody knows how to run a cell. Any issues? Anyone who is not aware of it? Okay. Are we able to display the dates? The series dates? Yes or no? Yes, Maria.
Yes, sir.
Are we able to display dates? Good. Now the problem with respect to this series that we have get as an output, that we have received as an output, is that this is not indexable. You have to consider indexes of the dates. I cannot do that. This is just a date data set or a date series that I have been able to create. And that is where the concept of timestamps as index comes into consideration. We want to create these dates as the index values because that is where time dependency will be reflected in any of the data sets. Today's date, what is today's weather? Weather is the key value or the data value, but index is today's date, right? Yesterday's date and the weather value, maybe temperature, maybe humidity, maybe air, wind pressure, something that has to be associated with the date, right? So here, the index value 0, 1, 2, 3, 4 does not matter to us much as the dates that the value is associated with that matters. So we have to create the date as an index of the data set based on which values can be manipulated. And that is what we'll see in the further domains. So this is a time series, again, a combination of functions from NumPy and Pandas both. We are creating a series, pd.series, where I am calling random values, random function generator to create 6 different random values, which would be kind of coming from standard normal distribution. So 6 values are coming. And what is the index now? The index is the dates that we have just set in above. I am explicitly setting the value of index as dates because my values are dependent on date. It has nothing to do with 0, 1, 2, 3. These are all dependent on date. I am not concerned with what happened at 4th index. No. What happened on Thursday is what is important to me now. What happened on 22nd September is what is important to me. Right? So creating a data set is very easy. We just have to create a series with respect to Pandas functions, and we have to pass 2 arguments. One is the data values, which I am generating randomly here, and second is the index, which is my dates. I have to create these dates column separately. Quickly execute. Are we getting different random values? These values would be different because these are random. For me, they will occur differently, and for you, they will occur differently. So the dates are similar. You have kept similar dates: 2nd, 5th, 7th, 8th, 10th, and 12th January. Right? So on 2nd January, what is the random value that you are getting?
1.97.
1.97. Maybe anything else for on minus 0. So all of you will get different values because these are random values. Right? Now this, we can assume this could be anything, let's say the rate of change of a particular stock with respect to yesterday's price and today's price, whether it has fallen down or moved up by what percentage. It's a very small percentage that we can say, right? It could be variation in weather, rainfall conditions, humidity, gold prices, Bitcoin prices, could be anything, right? So now what I have done is that I have created a structure which holds my date as index and values as my actual data point. I created that kind of a structure now. This structure is very important for us to understand because based on this structure only we will be doing all the manipulations. We have to understand the data, right? So we have to prepare it accordingly and then understand it. Now let's print the index values of the structure TS that we have created just now. Can you execute TS.index? Yes. Let's say we are comparing today's temperature condition with respect to 1 week's time span. Then every day of that week will become the index for us. From morning till evening, then it will become hours and times. The date will remain same. It will be differentiable on time and hours and minutes. That we have. We already have the flexibility in date time format. That here we can also specify the time factors, and that is differentiable even at microseconds. So at that level. Yes. Yes. So, I mean, this is again a very experimental kind of a work. You guys can also try with the time, hours, and minutes, right? Hour, minutes, and seconds, and microseconds also. The same thing that we are doing with respect to day, month, and year, the same thing can be done for hours, minutes, and time as well. So then in that case, the same date would be there, but it would be differentiable at time, and we'll see in further examples. Every 4 hours we are doing something. Every 2 hours we are doing something. We'll include that component in later examples. Right, so everyone has received the index values.
Yes.
Now the index are not 0, 1, 2, 3, 4, which is the essential or the kind of inbuilt index values in any of the series. Now we have converted that index into date format, and those dates are now indexed for us. Based on this, we can do the manipulations, and if you find out the values of the series, then ts.values would give you the column which is having the random values. You can quickly execute the two commands, ts index and ts values, and you'll see that you'll get the component that you're seeing as a series here. These two can be independently accessed through ts index and ts values. So frequency we have not specified, like every 4 minutes you need, every day you need, every month you need. So frequency is that kind of a component, and date time format at differentiable at nanoseconds level. This is what it means. Right. So frequency will again will be seen in later examples where you set up the frequencies every 4 hours, every 2 minutes. So there are a lot of times when we are monitoring something at a frequent rate. Right. Now, this becomes an important activity for us. Earlier, we were accessing all the time series. Now, here I am assuming that a bit of series and data frames concept you are aware of. Now, we have to access earlier with respect to a command. Let's say ts 0 or ts 1. This is a standard thing. Any element at a particular index in the list. Now I am not concerned with the index number. I am concerned with the date. What happened? What value was there on 5th January? What value was there on 2nd January? What value was there on 10th January? I do not care whether the index was 5, 7, 10, 12, whatever. I cannot keep a track of it because index is not holding any relevance to me now. Dates are holding relevance for me. And that is why now we are passing dates as an argument for accessing the values. And if you run this command, that means date being passed as a string inside the series object, you'll get the value being fetched. Clear? So what we have done is that we have converted a regular time series, a regular series from Panda into a time series kind of a structure. Clear?
Yes.
Similarly, you can fetch any other. Now, the beauty of this time series is that the true nature of series will still hold true. That means you can still access it using the traditional indexing of 0, 1, 2, 3, 4, 5. That way, still it will be iterable. That means if you want to create a loop around it, you want to put in some conditions with respect to index as I, that is still doable. So you are not losing the basic properties of series to this operation, but you are adding time as an important concept, as an important component in the time series structure that we have created. Clear? That we are not losing any properties of series, but we are just adding more properties to it. Another important thing that we see is that the index as in string, what we are passing inside the time series object, that can be taken up in multiple formats. Like here you will see hyphen is there, right? Between year, month and date. You may remove the hyphen. You may put backslash. Different kind of formats are accepted. Earlier this was not the case, but since with respect to dates we are getting too many formats to be processed. That's why inherently now the series that we are creating is considering the different formats to be considered as a index. So it does not really matter. You are putting hyphen, you are putting spaces, you are putting no spaces. Whatever you are doing, you are still able to fetch that relevant value. So that kind of a flexibility Python is giving you now with respect to when you're converting a series into a time series structure. Clear?
Yes.
Are we good so far? Fine. So what have we done in the first phase just now of second subsection? We've just created a time series object where timestamp is that specific instance. It could be day, month, and year. It could be day, month, year, hours, minutes, seconds, microseconds, seconds. Right. So that itself becomes a timestamp. Where all in which all applications do you timestamps in your transactions in your day-to-day life? Where do you see these timestamps? Google Forms. But I think they're just filling up. They're not seeing the responses. Most of the time they're on the other side. Right. You see a lot of timestamp because you are receiving the responses. Bank transaction is in bank statements, you see the timestamp as an evident index. So they will not say that zero at zero index in your passbook or at 51st index in your passbook, this entry is there. No, they just say on 22nd January at 5 p.m. and 5:34 you have done this transaction. They'll always talk in time series concepts or time sense messages. So messages, so banking transaction, whether it's email messages or passbooks, they are all timestamped. Any other place where do you see timestamps? Even in your product purchases or online retail shops, you'll see timestamp as an important element. You'll see timestamp in your Uber rides, Ola rides. What was its start time? What was the end time? Whether it took more than the estimated time or less than. So all these timestamps, the applications wherever you will see timestamps will actually see its usage in this format. Timestamp will be the index value for them rather than the data in itself. Right? Where will you see timestamp as a data? So some particular date is written and that is a data. That's not a timestamp. That is not an index. That's a specific column date.
So birth date in a
Birth
form.
date in a student forms. So in
Date
college
of-
administrative records, that date is a data. That's not a timestamp. So you should be clear with this. That's not a time series data. So that's just a record that college is having with respect to the students that are enrolled in that college. Clear? We're clear with the difference between timestamp and time data. Right? We should not confuse this. Right, that's an attendance management system. Right, so that's more of a data that you are generating. It is not used as an index value. It will only be used as a data point to compute, let's say, your working hours, the efficiencies and the attendance. Right. Now, once we have created a timestamped data, now we want to fetch the information out of it. And for that purpose, what we initially saw was an operation which is prominently used called as slicing. Right? Slicing का हिंदी meaning क्या होता है? Partner. Right? We make slices out of anything, like any fruit or vegetable, we are just slicing it. The same way we are cutting data at a peculiar point. We are slicing that data at a peculiar point. That is why this term slicing has been coined, right? Now, slicing operations are being performed with respect to operator, which I just told before these sections, which is colon, right? So there are multiple ways how to slice. The time series data also allows us to perform any sort of slicing operation, which is inherent properties of series and data frames. We're creating panda structures, right? Now we are not deviating anything out of pandas and NumPy in today's session because they are very powerful and they give us a lot of good flexibility to be able to fetch the information. So slicing is something that we are able to get. So let's say if every second element I want to access from my time series data or my timestamp data, I just specify double colons and I specify second or two. That means I am able to fetch every second element right from the first element onwards. Right? So that is picking up some portion out of my timestamp. Why would I need that? Let's say, I don't know if you were all aware of Big Bazaar used to have sales on every Wednesdays. Why? Because that was the point they were having lowest sales in their stores. To increase the sales, to increase the footfall, they identified that every Wednesday of my week, for the past 1 year or 2 years, I am seeing low trends regularly. So let me put some strategy around it. Let me announce a sale day on Wednesday. And let me just, it was a big hit. People used to buy on Wednesdays. So footfall immediately increased, right? What was that operation? They were using slicing to find out which all days we are seeing as high volume or low volume days, right? So quickly, can you execute these commands? TS double colon 2 or TS double colon 1. 1 means every other element I am accessing. 2 means every second element I am accessing of my time series. Can you quickly see what results do we get for every third element that I want to access? TS double colon 3. Ideally, we should get just 2 rows as an output, 2nd and 8th January, right? So TS double colon 3 means every third element, and since we have very lesser number of elements, so just 2 elements are returned as an output. Clear?
Yes.
Now this is one way of slicing. Similarly, I can also access it through index that I've already told, so I will not spend much time on this. That in case we don't want to access it using the timestamp, I can also access it using the index value. So directly 0, 1, 2, 3, 4, I can directly use the index value to fetch what is the timestamp. Okay, let's create a longer time series now. Longer time series so that we can have 10 days of data values now. Right? Now, what was the format that I specified? PD.series, this is same as we used above, that we are creating a series. The first was the data. So I am creating 1000 random numbers now. Right? And I am also randomly creating a date range, which is used with respect to a function called as date underscore range, which is again a function available in pandas. You can access that. So pd dot date underscore range, I specify the start date and the number of days that I want to span up to. So I start from 1st January 2021 and I say that randomly create 1000 values for subsequent days. Subsequent days starting from 1st of January 2021. So what should be the output of this series? We should get a structure with dates, 1000 dates from starting from 1st January 2021. So that means 365 and third year. So 2021 entire, 2022 entire, and some part of 2023. Because 1000 days, if we divide by 365, we'll get somewhere around 2 point something years, right? Why do we have to create such a long time series? So that we can just see more number of slicing operations. We were just looking at a 6 or 7 values up till now. Let us look at 1000 values now. And this goes up till 10,000, 1 lakh, 10 lakh, 1 crore, and 10 crore, depending on which application you are dealing with, right? Okay, are you able to create it? Longer time series is what we are calling that.
Yes.
We created this time series object,
Yes, sir.
longer underscore ts
Yes, sir.
at the back. Done. Okay. Now we have got a lot of flexibility in terms of how do we want to access the different data types, data sets or subsets. Slicing is all about getting some chunk out of the data. Now I need not to specify the exact date. Let's say I want to just fetch yearly data out of this longer time series. I can just mention year as my index value in this series. I'll get data points only for those years. That means I should get values which are applicable in that year itself. This is the kind of flexibility that we get when we are using time series objects with series under pandas. We need not to specify the entire date, or we are not using any operator at all. We are just mentioning the year. How many values are we generating in 2023?
270.
270. Can you quickly tell me how many values are there in 2022?
365.
It has to be 365, right? Because the entire year is what we have covered up. And can you quickly check for 2021? It should again be 365. If that's not the number that you are getting, then probably we have done some mistake, right? But are we getting 365?
Yes, sir.
Yes. So that means 365 for 2021, 365 for 2022, and 270 values for 2023. Entirely spanning up to 1000 values. Yeah? Okay. Similarly, we have got another flexibility that I want to specifically fetch for a particular month of a particular year. Again, I just need to pass the of the year and the month, and my job is done. Now, this is slicing at the easiest form. I'm extracting certain amount of data from my longer time series object, but in a very minimalistic effort ways. I don't have to use any operator. I do not have to use any sort of loops, conditional statements. I am just specifying the values which I want to fetch, and that's it. You can store these results in another variables for the monthly trends that you want to understand, any sort of analysis that you want to do with these values. But sorry, quarterly के लिए we cannot mention it accordingly. We'll use the slicing operator before time, after time. That is just show. Right, so whatever dates and months we are having, we can fetch for that respective year. So now can you just confirm with respect to any of the month how many values you are getting? Let's say, let's look for February 2022. So we'll pass 2022-02. That would be for Feb. You must be getting 28 values. Right? Now at the bottom you will see something called as frequency. Frequency D means that it's a daily transaction that you are getting, because we have mentioned by default when we were creating the series object, it took operations. It has taken dates which were adjacent to each other, which were subsequent, right? You created. So that will be reflected in all of your outputs. That what is the frequency of this data? This is on a daily basis. This could be annually also, this could be quarterly also, this could be monthly also. We'll see later on. Right. Now comes the slicing part with respect to slicing operator. If we want to fetch data between specific dates, we can use the operator which is colon. Now, so there are two values which are alongside the colon. The left hand side is known as the start index or the start date, and the right side value is known as the end index or the end date. When the start or the end is not specified, that means we have left vacant, then by default it considers the start of that series or frame index or the end of that series or frame index. Right? Like here, I have not mentioned or specified the end date. So that means I should fetch data right from 1st January 2022 till whatever till date we have the data for. Right? How many values are we getting here? 635. Is it the right number? 365 plus 270. 365 plus 270. That's what we were calculating, right? Clear? So we have now used the slicing operator to fetch the data between a specific date till whatever is the recently available data with that we have, and not specified the end date. Let's say I want to fetch data between specific dates, then I'll specify the start and the end date. Now here, what I'm doing is that I'm fetching data between 5th January and 1 January, or 1st January and 5th January. I've just specified the days in month, day, and year format. So I'll get 5 values being coming up. So you can play around with a lot of different values, lot of different ordering of year, month, and dates. That will give you a lot of different kind of answers, right? Yes.
So normally when we slice, isn't the end date exclusive?
These are both inclusive dates. Whenever we are specifying start and end date, both of them will be inclusive. That's a by default behavior of time series object.
Okay.
Right? This is clear. So can we quickly find out or slice the values between your birthdays in 2021 and 2022? The values sliced between birth dates of your birthday in 2021 and 2022. We should get how many values?
365.
365. Are we getting 365 values at a daily frequency? 366. Why? Because both of the dates are inclusive. Right? Because that's not an by default end that's been computed as a series object. Usme humne, what we said to the machine was that you should consider whatever till end we have. So till end there is no specific time or date that we can understand whether we have got any number of days or not. So it was showing us 635 as the specific number of days that were there. Here, right. So for this, you can compute the time delta. The time delta that we have done in the first subsection, you can compute time delta, access the number of days, and utilize it for any of the programs. Because whether slicing it like this or performing time delta for a number of days, it's one and the same. Right? Okay. Similarly, we have a very good function called as truncate that's available to us, which we can apply, which specifies the data points after or before a certain input value. Let's say you want to truncate after 1st January 2021 or 2022. That means whatever values were there from 2nd January 22 till the end of the data in 2023, that will all be truncated. Only before this data would be available. So truncate means cutting the data after this particular time interval. Clear? That's also a kind of slicing that we do. And similarly, we can use before as one of the options to truncate or cut the data before a particular date. So again, sometimes it happens that the data has become irrelevant for us. We want to remove that for better understanding, and let's say we are creating graphs out of it. We are just using some of the data points. Clear? So can you quickly just execute these two commands and see if it's working fine? Great. Then let's move to the data frames now. Now, with respect to series, with what we have seen is the time series objects that we were able to create. But now, with respect to data frames, what is the difference between a series and a data frame? Anyone?
Single dimension and
Single
data
dimensional and
frame.
multi-dimensional. That's a very basic answer, right? Now, we were considering only just one value within the series. Now, we want to consider multiple values within the series. And for considering those multiple values, we can utilize the structure in pandas, which is called as data frame. So until till now, we were creating with respect to pd.series. Now we are creating with respect to pd.data frame. In data frame, again, I am considering random values, 100 random values across 4 columns, 100 by 4. Right? And what are the index? Index is my dates again. So dates I have created. Now dates is a very specific thing. Starting from 1st January 2022, period is 100 days. Now I am not, so by default in the previous longer time series, we gave the by default frequency as daily. Now what I am doing is, I am saying I want to create dates data with respect to every Wednesday starting from 1st. So I have said weekly W-Ved. That's the short form for Wednesday. So now I will be able to get 100 consecutive Wednesdays starting from 1st January 2022. Right? How many Wednesdays are there in 1 year? 52. Why? 52 weeks are there in a year. That's another. Sometimes it may happen. We get 50 Wednesdays. It may happen. Why?
Leap year.
So leap year is Wednesday. Yeah. So that we have some days which are left out of that. Right? So this again, this is a very peculiar thing that may happen. But again, so if we are counting 100 days or 100 Wednesdays starting from 1st January, it has to span across 2 years. Right? And that is what we are seeing in the data frame. Right. So the way you have this frequency as W-Ved, that means weekly Wednesdays, you can try it for weekly Thursdays, weekly Saturdays, weekly Sundays, and so on. Clear? Now the data frame that you are seeing here is that every week's Wednesday has become the timestamp for you. And then the 4 columns that you have specified, we have got different random values across those 4 columns. Now it could be the temperatures across these 4 cities. It could be again census values. Census values are common in India, so that may not vary with respect to the cities, but it could be pollution levels, AQI values, right? So we have different values occurring in the same data set with respect to features, which is timestamp, and that is where we want to create an object which is a data frame in nature, and most of the data that you will capture, that you will get, will be in the form of data frames. So we are just creating a data frame. Again, now with respect to data frames, the beauty is that either you can access it row-wise or column-wise. Let's say I want to access all the 100 values of Mumbai. I can just specify Mumbai as the column name, and I'll get all the values of Mumbai. Let's say I want to get the December month's data for all the 4 cities. I am just specifying December as 12, 22, and I'm using a specific, in Now in data frames, we are using a function called as log, which is used to access specific locations. And those specific locations in data frames are that all the Wednesday's data for December 22 I require, and I am able to access them in my data set. Quickly execute this. Are you getting the same data? Maybe for January 22, can you fetch the data? The data frame, can you fetch for January 22? Right, we just replaced 1, 2 with 0, 1. And that's it. So we would get for 4 Wednesdays in the month of January for Mumbai, Chennai, Delhi, and Kolkata. Clear? Simple way of slicing the data frame. So by year, by column names, by dates, you can do that. Now, this is the last subsection in this particular second section, where sometimes it happens that you have duplication in the index values. Essentially or originally, none of the time series or data frame object will have duplicate index. Index is unique. Index is a key value. That is why inherent properties are preserved. But when we are creating time series objects, we can have duplicate dates. For example, let's say I am just tracking on which all dates this particular product was being purchased. So in a given day, there could be multiple purchases of the same product, right? So there we can just group these kind of product ranges with respect to group by functionality, right? So let's quickly see that. We have created a datetime index with respect to multiple same dates. So I've given 1st January, 2nd January, 3 times 2nd January, and 3rd January. So there are total 5 dates that I've created. 1st and 3rd January are once, and 2nd January is thrice. Right? And I've created values from 0 to 4. So 0, 1, 2, 3, 4, these are values that I've created for my series. Now you'll see 1st January, the value is 0, 2nd January, the value are 1, 2, and 3. 3rd January, we have value 4. That's fine. That can happen. It is something that is very general in reading, that on specific days, you have same product being purchased. Now, what is it that we can do? First, we always want to check with our data set whether my timestamps are unique or not. So I'll say the series name dot index dot is unique. If that is false, that means there are repetitions. This is a very simple data understanding check that I can put in on my data set to understand there are any duplicate timestamp values or not. If there are, then of course I need to work around them accordingly. If there are no unique values, it will return true. That is, yes, the timestamp is unique. And you can try with different kind of combinations. Now, once I have that, now let's say I am accessing my series with respect to the duplicated time as an index. It will show me all the observations that were there. It will show me all the observations for 2nd January. While for 3rd January, there was just one. So I just get one observation as the value only. But when the values are duplicated, I'll get the date as well as their values. So on 2nd January, I have 1. On 2nd January, I have 2. On 2nd January, I have 3. Now the point is that I want to group by them. I want to combine what is the value that was there on 2nd January. I can use a function called as group by, and I have to pass a parameter called as level that 3 groups that would be created here. First would be 1st January, second group would be 2nd January, and 3rd January. That means how unique dates you have, how many unique timestamps you have, there those many groups will be created. Right? Now, on that grouped data, either I can apply count, that means how many instances are there for each group. Count will give me 1st January, we just have one instance. For 2nd January, we had 3 instances. For 3rd January, we have 1 instance. So again, I am just getting the count, right? I can find out the averages. I can find out the sum. So with respect to groupings, I can do any sort of arithmetics that I want to do with respect to finding the averages. For example, what was the average revenue that we generated on 22nd January 2022? I can simply group by and find out the mean of that group. It's a simple operation. So these are, again, this is also slicing and dicing, part of slicing and dicing, where we are just trying to understand what are the key measures that happen on a particular time stamp. Here, how many products were sold on 22nd January 2022. I just need to find out the group count for that day. Right? These are business questions that business people will give you. Tell me how is my business doing? And as an analyst, as a scientist, you will perform these commands on your time series data and give them the answers. Most of the time, these are automated, and the automated values becomes part of the dashboard, where you will see some key metrics being shown as a part of the dashboard. Right? So this was all about slicing and dicing, which is a very important and essential part of time series frames and structures. Any doubts till here? All of you are able to execute the commands? The levels in this Python notebook so that all of you are able to access it in a very neat manner, right? Otherwise, this would show you 1,000 cells, right? You can just open up any of the, and all the learning outcomes and the objectives are also written so that you understand what exactly you want to learn from this notebook. So this will be a handy tool for all of you. Okay, so let's take a break, right? And let's reassemble at 12, right? Now for the operation, most of the things are done. We have understood how do we handle timestamps, how we do the slicing and dicing. Now there will be further more operations that won't take much time, so we'll try to end it up in another hour or so, right? Okay, see you at 12.
Yes, ma'am. बहुत हेल्पफुल है मुझे सब आ रहा है समझ में।
basically. Okay, shall we start and quickly settle down? Okay, computers are on for everyone. Now let's come to the third subsection or third phase, which is with respect to data ranges, frequencies, and shifting. Now, let me tell you that most of the functionality we have covered in the first two subsections. Those are the major areas that we generally focus when we are understanding a time series data set or time series, we are creating a time series data set, right? Now, whatever we'll be doing, we'll just go through the overview of them and we'll just keep on executing because these are things that we have already understood as a concept, right? So now in this section, we just want to understand how to shift time series data and manipulate the dates. Now, dates manipulation is also something that is required heavily on day-to-day operations, and that is what we can do. So we are just taking the example of the above time series object only that we have created as a series with respect to timestamp and some random values. Now, your random values must be different than the ones shown on the screen because the random values are created differently for everyone. Now, resample is a function that is very, very, very important in time series functionality or time series objects. Now, resampling generates a unique sampling distribution on the basis of actual data. We can apply various frequency to resample our time series data. अगर इसको बहुत ही बेसिक लेवल पे if we just try and understand, resampling simple means that let's say we are just either rearranging or filling certain values inside the missing values with respect to time series data and so on. The utility of resampler. That is what we are using resampling for. Plus, let's say arranging the data with respect to certain frequencies. Daily frequency, annual frequency, monthly frequency, weekly frequency. What kind of resampling that needs to be done is what is also being specified. And we'll see how we can fill the missing values with the help of resampler operation. So these are the two important utilities that we see when we are using resampling as an operation onto the time series data. So what I'm doing is that I have created a time series object and I have created a resampler for myself. Now resampler is that I want to resample this time series on a daily basis rather than on a weekly or a monthly basis. I can use M, W, I can specify the week, which day of that week, just we saw with respect to week Wednesdays, the frequency that we change. So those frequencies will be used in resampler as well. Now this is just to show how resampler is created using resample function and how we can apply. We'll see how we can generate the dates accordingly. Now let's say I just told you that date range inside pandas is a very useful function to create specific types of date between certain ranges. For example, I am creating between 1st April till 1st June. That means entire April, entire June month dates should be available along with 1st of June, right? So as you can see, we have generated all the dates here. Now this was the first step that we started in the first section, that we created a date range and then we used these dates as index to create time series objects, right? Everyone remembers?
Yes, sir.
Right. So now more date ranges can be created. Now let's say I would just want to give a start date and then give the periods in the sense for how many days I want to get. If I am not specifying any other specific thing such as frequency, it will consider by default as the daily frequency for creating the date ranges. So this we have already done, just giving you an insight so that once we build upon these functions, we'll be able to understand them better. So just revising them again. Similarly, I am just creating 20 days dates starting from 1st of June. So now you'll see a specific difference. In the above cell, I am giving the start date. Sometimes I need to know the end date, and prior to that, I need to generate my date ranges. So either I can give the start date as an input parameter, or I can give the end date as an input parameter. So in both the cases, my date ranges will be generated. So this is an important utility. Let's say I want to analyze that before, let's say 25 days before today, what was the product sales trend that we have seen? What is the product count that we have seen? I can use these functions to create date ranges, insert it into an index, use the values that as product selling, let's say product revenues or product selling points, and then I can utilize even group by functions. So now you are able to relate the functions that we have seen, right? We are using group bys, we are using the date ranges, we are creating the time series objects, and we are answering the business queries as well. This is the way how you look at the time series data to understand the different points that needs to be answered. So both start and end date are crucial to us. We can either create our date ranges before a specific date, and we can create date ranges after a specific date. Now here comes a variation. We can also have the start and the end date being present, and we can give a different frequency other than daily. This is the business month end, right? So the end of every month will be displayed here as a data range. 31st January, 28th February, 31st March. I don't know why 29th April, but it is showing as business month end. Maybe in certain calendars, they are considering 30th April as an off day. That's not considered. So this could be the reason. but usually they will give you the business month end dates, right? So it may vary depending on certain considerations, but BM is generally used for end of the month calculations. Similarly, you can give timestamps in form of hours, minutes, and seconds. So we want to consider from 2nd of May what has been my daily instance at this particular time. Right? 2nd May, 3rd May, 4th May, 5th May, 6th May. At this specific time, I want to check certain values. So I'll create data ranges accordingly. Now we are just understanding in what different ways we can create the data ranges, which can be put into an index and the values can be analyzed accordingly. Right? So till now we have just considered one way of creating data range. Now we are seeing the multiple ways of creating data ranges based on the specific needs of the different use cases. Right? Why do we need a specific timestamp every day? There could be a periodic activity that is happening every day at that specific time. Right? What could be the application of it? Sorry? Online classes. Yeah, that can be a periodic thing at a specific time of every day. Yes, that's correct. So you get a reminder, and this could be regular. So this we generally in our office operations we see with respect to Zoom or calendar invites. Let's say we have a daily meeting with some specific group every day. So that reminder will be taken up, and that will be stored as a day plus hour, minutes, and time format. Right? Now let's say I want to normalize. I have got the hours, minutes, and time, but they are not useful for me. I can normalize. Normalizing means it will remove the hour, date, and time because it may be same. So it does not make much of a difference that you are adding the hour, date, and time, hour, minutes, and seconds. Right? So either we can just remove them or we can put it. Clear? So these are different ways of data ranges, how you can create the data ranges and then create your time series object accordingly. Now let's cover hourly level interventions. That means now I want to intervene at hourly levels. So what I'm doing here is that I'm creating a date range between two dates. Now first one I have not specified. So start date, the hour, minutes, and seconds would be by default 00000. Right? And the end date I'm keeping is 3rd of January 23:59. That means just before the day ends. Right? 00 means it will move to 4th January. Now I want to have the data at an interval of every 4 hours. Now this was a specific or a classic case of DU admission process. The DU admission process used to open up for this 3 days in cutoff list. I'm sure all of you are coming from through cutoff mechanisms, right? Every 3 days, the college administration used to see every 3 hours or 2 hours or 4 hours how many admissions have been done so far. And the cutoff date was specified. In the system, after a specific date and time, no more entries can be adjusted, right? So for those 3 days, let's say I want to create a timestamp that I want to see how many students were admitted for every 3 hour, every 2 hour, I can create this timestamp with respect to start date, end date, and a frequency of hourly level. Clear?
Yes.
Right? So this is, we just mentioned 4 hour of frequency. You can also mention minutes. You can also mention seconds. So both of these options are available. I can also combine 1 hour 30 minutes. That means hours and minutes can be combined as well in a specified format in a sprint. So I'm starting from 1st January. There are 10 periods that I want to monitor, and those periods can occur or should occur after every 1 hour 30 minutes, or I can also say 90 minutes. Clear? Either I can say 90 minutes or I can say 1 hour 30 minutes. It's one and the same thing. So this is how you can do hourly level interventions. I'm not going into depth of this, but these are very straightforward assumptions. So now the data ranges that we were creating till now were only based on days, month, and year. Now we are seeing hours, minutes, and seconds. Now what does this mean? Can anyone tell me? Week of the month, every third Friday. Every third Friday of every month. That means we just have one instance. Maybe it is, Fantastic Fridays. Maybe some offers are running for a retail store just once in month. And this happens. This happens with respect to credit cards a lot. They come out with deals which are specific on specific days. So for example, if you see the online website, you'll see today we have an SDFC offer. Today we have an ICICI Bank offer. If you have an RBL credit card, you'll get 20% extra discount. These offers and discounts are based on this logic. Every month they'll roll out an offer on a specific day of that month. Similarly, let's say a Starbucks comes up with a sale that every third Friday of the month will have some extra offer for you to get maybe 200 reward points or anything like that. So the level of detailing that you can put in time series objects is really wonderful now. So you can create your date ranges at any level, use them as index in timestamps and utilize any values in that series or data frame to analyze any of the data points. Clear? Similarly, we can also do some sort of shifting of the data with respect to the values that we are having on a particular date. For example, if you see, I have created a time series object. Now I am not explaining what I have done here. This is something that we have understood by now, right?
Yes, sir.
I created a time series frame. I want to shift the values by 2. So both the values which were above should shift now. Many a times we have to manipulate our data set in such a way that incorrect date has been mapped to incorrect value. This is with respect to when we want to have some sort of date corrections or value corrections with respect to dates, right? So let's say some sales were recorded maybe 3 days after it happened actually. We have to shift it up. Sometimes we have taken it up a bit earlier, so we have to shift it down. So shift the data upwards and downwards. Shift operation is very helpful with respect to the frequency that we want to give as the number of days, and your dates now will have the correct data being mapped to that date. Right? Now I assume that you are also executing these commands parallelly, but it does not mean that these are tough commands to run. So even if you are not able to do this, that's perfectly fine. Now just see, I have done positive number, so it will shift down. If I use negative number, it will shift up. So since there were just 4 values, so just to demonstrate, I'm just showing you that the data, the values which were associated with timestamps, they were not correctly mapped. For that purpose, either we have to shift down the data or we have shift up the data. And this can be done with respect to positive or negative index value inside the shift operation. Clear? We can also specify frequencies as months, days. Daily would be the by default frequency, or every other transaction. We can also utilize the other frequency modes, weekly, monthly, annually, and so on. Shifting can happen with respect to months also. So I'm not going into these details because these are pretty straightforward operations, and we have a lot of such other operations to be going, to be covered up. So I'm just giving you an overview that what is happening. These commands can be run in a very simplistic manner. Now we have seen the slicing, dicing, and the manipulations and the object creation parts. These are just extensions of those concepts that we have studied now, right? Now let's say I want to give the frequency of 90 minutes. Now minutes is not M because M is for months. So minutes we use by T. That's the only thing that I wanted to highlight here. The frequency instead of 1 hour and 30 minutes, if you just want to write minutes, then specify it with T. And that will give you the frequency of 1 hour 30 minutes starting from any of the brackets, any of the starting point. Where 1 hour 30 minutes, every 1 hour 30 minutes, I'm just looking at the value for the different dates, which I have computed above. And similarly, you can use offsets. Offsets we have already covered where we were distancing the dates. Let's say from now, what is the date 70 days later on, or 20 days later on, or 20 days and 3 hours later on. So those kind of detailings can be covered up with the offsetting part. So again, this is another concept that you can go in depth. You can also use month ends to add from the date now, which will roll up to the next nearest date, and then add 3 months to it. So again, the 4-month day and month date will be showcased. For example, now 3 months will be added, and 31st January 2023 will be shown. So October, November, December are gone and being shown from now. After 3 months, what would be the month end date? So 31st January 2023. So these are very small functions, but very useful when we are doing the data manipulations. And those data manipulations, what choice of operation we have to perform really depends on what use case we are solving. Right? Let's say I want to end up sales after every quarter. I can use now plus month end. I can use every quarter plus month end dates to sum up what I've been able to generate after every quarter. So this is kind of very powerful. For example, roll forward and roll back. This is just rolling the way you use ceiling functions or the floor functions in integers. The same way roll forward and roll backwards are used to round off the dates up to some nearest number. So maybe it's the month end, it's the month beginning, and so on. So you can, the way you can round off an integer value. Similarly, you can roll forward or roll back to a previous month value or the next value. So those kind of operations can also be used under the offset. Right? These are very small functions, but very powerful. So now I have combined. Now see, now the complexity is increasing. We saw group by dot mean with respect to similar dates. Now in group by, at what level I want to group by? Let's say I want to roll forward the offset. Consider grouping of all the month ends. That's why I'm forwarding it. So nearest next month date end. At that level, I want to group by the data and then find out their means. So this sounds very complicated when if somebody asks you to do that, give me a report that on an average, or rather how many sales, product sales happened for the entire, let's say August, right? You'll keep on counting the traditional ways, but these are the ways you can roll backwards or roll forwards, group by on the dates, find out the count, mean, or sort the values. You can do any operation, any arithmetic operations, that's it, right? So we are just increasing the complexity of what we have studied so far. And similarly, we can use means, we can use counts instead of this, and we can use sorting values. So this is all about how you are using the different set of resamplers. The resamplers essentially meant that we are just trying to create data points in an ordered manner at hourly level interventions, at minute level interventions. So primarily this was the focus of this particular subsection. There is nothing that is being used independently here. everything is being used with group by or some sort of data range creations, which becomes a time series object, and then you are utilizing the values for any sort of operations. Clear?
Yes.
Any doubts? So, things, hourly levels interventions, and data range creation. This was the main objective of the section. So, and now you can use offsets and shifting the dates. You can shift the values also up and down. Clear? Fine. Next section talks about time zone handling. Now this is an important use case, and this is very specific use case if you are dealing with world level data, as in data at global level. Let's say the data is coming from Australia, the data is coming from, could be any place. Now, when the data is coming, the time zones are there, right? The timestamps will be local to that region. Therefore, there should be an interconvergence between the different time zones. And those time zones we have where I will not get into depth, but I'll just show that there is a library of each time zone